Hello, today we're going to learn about the changes of scale factor and how they affect the perimeter and also the area. We're going to start with scale factor and its effect on perimeter. If you notice in the graphics, you see a square. It's a 3x3 square. We know that squares have all congruent sides, so let's go ahead and label our squares. And we have a scale factor of 4. We know that to get the larger square, we had to multiply our original or old side length times 4 to get 12, the new side length. So since the dilation has a scale factor of 4, each side is multiplied by 4. Since we're talking about perimeter, we're going to go ahead and find the perimeter of the old square. So go ahead and add up all the sides, because perimeter means to plus the outside rim. And we get 12, because 3 plus 3 plus 3 plus 3 is 12. Now we're going to look at the new square. The new square, we want the new perimeter. 12 plus 12 plus 12 plus 12 is 48. Therefore, the perimeter of the square is simply multiplied by the scale factor. And that's all you do for perimeter. Now let's discuss the effect of scale factor for our area. If you look at the graph, it shows a dilation with a scale factor of 3. So out to the side, let's go ahead and make our note that we read in our words, scale factor 3. How was the area of the figure affected? This time it's discussing the effective areas, so we have to do something special. If you look at the picture below, we notice that we have 2 rectangles. What we're going to go ahead and do is we're going to go ahead and label the dimensions, the measurements of these rectangles. The smaller rectangle is measuring 2 squares by 1, and the larger rectangle is measuring 6 by 3. So since the scale factor is 3, we know that the dilation represents a enlargement. The reason why we know this is because our scale factor right here is greater than 1. If it's greater than 1, we have an enlargement. If it's less than 1, we have a reduction. Let's keep learning. The area of the pre-image, that's this one right here, is 2 by 1. So what is the area of this square? 2 times 1 is 2. It is 2 square units. Now, the area of the image that we did was 2. Let's go ahead and do that for the larger one. The area measures the space covering, space inside. So if we do that for this, we have the area of the smaller one is 2, and the area for the larger one, what's 6 times 3? 18, very good. Okay, so we have 18. So the ratio is 18 divided by 2. When we divide that, we get 9. Don't panic that your scale factor was 3, because since it was talking about area, and area is measured in square inches or square centimeters, we have to actually take our scale factor and we have to square it, because this is a 2-dimensional shape we're talking about. So at the bottom, the area of the figure was multiplied by the scale factor 3 squared, which will give us 9. So in our statement, we could say that the larger rectangle is 9 times larger than the smaller rectangle.